Hello, everyone. My name is Anurag, Pamuru, and this is my workshop on AWS for the DS3 Workshops Committee. Today, we're just going to be looking into a couple of different topics, starting with just what is cloud computing, the pros and cons of cloud computing over on-premise, traditional servers, and then we'll look at AWS, which is one of the prime cloud computing providers nowadays, and some of the services they provide, and some sample use cases that you can make with those AWS services. And after that, I'll be providing you with some small links and resources. So let's get right into it. Well, first of all, we have to start off with the question of what is cloud computing. So it is one of the biggest revolutions in the software industry as of the past 5, 10 years, where you have the practice of using a network of multiple remote servers hosted on the internet to manage, to store and process data, rather than using a local server or a personal computer. And how this manifests itself into daily practice in most companies is that you have big companies like Amazon, Google, Oracle, to some extent, who rent out these huge, different servers in these huge server warehouses to, everyday users, to large companies, just across the entire spectrum. Everyone can use cloud computing to serve their, computational needs. But, uh, you know, the question, it begs the question, why do we use cloud computing as opposed to using traditional compute, on-premise compute? Uh, in the past, what was more common was that every company, if they wanted to go through with having, a online presence, or having like software applications, they would build their own on-premise servers uh, that would be built to deal with all of the compute liabilities that their services required. And this was the case with Amazon as well. And in fact, in the early to late 2000s, Amazon actually realized that they had too many, too many of these servers lying around that weren't getting used. So the question immediately became, what do we do with it? And their answer was renting it out to other companies that needed servers but couldn't use them. So you have some servers at Amazon that, maybe when they're low traffic, and Amazon isn't seeing too many customers coming through their website, they can lend the other servers to other companies that need them in the area. So these companies, these other companies that didn't have their own on-premise servers, could start, using Amazon's. So, Amazon had something to do with the kind of the dead weight on-premise servers that they had lying around. And this had, by the mid 2010s, sort of, blossomed into this huge industry of cloud computing. And there's three main domains inside cloud computing, three types of services within cloud computing. Um, we have software as a service, which is items such as, Gmail, Trello, Salesforce CRM, Google Docs, these like very popular open source softwares. Oh, or they could actually be paid services as well, like Office 365. You have Slack. Um, a lot of the services that you use are actually software as a service. Um, and these are like kind of the top of the pyramid, and these go directly to the end users of the compute. So, for example, Gmail, right? There you can have some administrators for like an Office Gmail server who have some level of moderation into how, Gmail works in their specific office space, but it's mostly a finished package. You can embellish it a little bit on the top, but that's kind of just what you're getting. That's the full package. And then we have platform as a service. This gives a little more leeway to software developers. So these are items like Heroku. If you guys have used that before, it's a popular web platform for development. AWS Elastic Beanstalk and the Google App Engine. These are not as prepackaged as the software as a service items. So you have more control. You can see this gradient here as to how much control you get into the actual implementation per each level. And or platform as a service is definitely giving you more control than software as a service. Like the amount of modifications that you can do with platform as a service is a lot more than software as a service. And the same is even more true for our final level, infrastructure as a service. So it no longer are you getting this kind of platform to build your own applications on. You're actually just getting like just computers. You're getting servers themselves, and you are given full control, as much as is reasonable, over how to use these servers to accomplish whichever tasks you want. So, for example, if I was trying to build an email service, I could just use Gmail, and I wouldn't really need to moderate, the usage, or like I wouldn't really need to modify Gmail for use in my office. Maybe I have like a certain like color scheme or something that I want, or I want there to be certain privacy settings. But perhaps that's like just about it, for software as a service. And you can't really do too much beyond that. For platform as a service, now Google App Engine, you can basically build any app, but you still have to build it within the constraints of what you can, build on an Android device, for example, right? Or Heroku, you're still building it within the constraints of, what you can reasonably do on the web. Meanwhile, infrastructure as a service, you are getting access to the server itself. And this gives you the highest level of control. And you can see like which uh, levels are meant for which kind of consumers. Software developers usually use platform as a service. IT administrators usually use infrastructure as a service. And software as a service is mostly for end users. And that is generally how the hierarchy works for the different types of cloud computing. And we'll show you some examples of this in AWS in just a second. And now that we've looked into what cloud computing is, let's think about what its perks are over traditional computing. Well, the first is scalability. AWS, Google Cloud, and Microsoft Azure, those are the big three. They all have systems of scalability built in to their cloud computing services. So, for example, we have Amazon here in AWS. If you have low demand to your website, your service, then AWS will automatically scale down the number of servers, EC2 instances, that you are using to match the demand for your certain service. And this is really important because um, you don't want to have a lot of servers lying around that you're not really using at a low demand period. And that is a con of on-premise computing. You can have a very large company that has a lot of demand, maybe during the evening, but during working hours, like 9 to 5, you see very low usage of your website. And if you want to account for that in an on-premise situation, you will just have dead weight servers that are lying around. You will always have these extra instances. But using cloud compute allows you to forego this and uh, you know, uh, pay only for as much as you use, pay as you use. And one con of this scalability and this sort of And then our next perk is security. Now, when you have your own on-premise server, uh, there's also a lot of costs that you have to deal with in terms of securing your securing your servers. And you would usually have to make your own in-house solution for security, but if you use cloud providers like AWS Cloud, they normally provide you with cybersecurity services that are part and parcel of their service as a whole. So, for example, if I use a EC2 instance at AWS or I use Lambda, I immediately have AWS's own in-house cybersecurity system that is automatically protecting all of your data as it enters and as it exits and as it resides inside of your servers. So that is something that is a huge perk. And you can generally assume that companies like Amazon and Google Cloud will do a better job at protecting your data than, for example, your own company's cybersecurity solutions. But this does have some issues, as if someone figures out the way to break into AWS's security protocols, for example, it has implications for all users of that cloud service. For example, some security breach that occurred to AWS's S3 buckets, which are their storage service, led to a huge breach of Capital One users' information back in 2019. But these kinds of events are far and few in between, and generally, you're saving a lot of costs on security if you go for cloud computing. And finally, I've been kind of alluding to it in the past few slides here, but the most, uh, the largest benefit of cloud computing over on-premise traditional computing is that the elastic scaling systems that we mentioned as the first perk of cloud computing allow you to essentially only pay for what you use. Whereas in a traditional sense, or in a traditional on-premise server, you would be paying for the power for all of your servers, regardless of how many you use. You have a huge warehouse, and even if you have low demand, you're paying for the full overhead of using all of those servers, even if you only really needed, 5 or 6 of them. And you can totally avoid this using AWS, and that is one of the perks. And this this type of this type of scaling this type of scaling essentially saves you often more than 50% of the costs that would be associated with running a small sized business or a medium sized business. The only con is that because you are scaling up and down more rapidly, right? AWS essentially has a bidding system that they use where users don't technically own units like they do in on-premise computing. They're bidding for uh, units that Amazon has at certain rates. And the rates are going to be higher in hours where AWS as a whole is seeing more usage, and lower in hours where AWS is seeing less usage. So we essentially can assume that there might be some unreliability in your capability to find on-premise or on-demand units from AWS. You may have to pay higher prices in high usage hours for using AWS, but this is a small con considering the fact that even with these high prices during high demand hours, you're still paying a lot less than you would pay for in a traditional computing sense, because you're only paying those higher rates when there is high demand, as opposed to a traditional system where you're paying a flat rate even when you're seeing very low demand for your service. And those are three of the many perks over traditional computing, but these are the biggest ones. Uh, it is essentially more scalable, more secure, and of course, there's more savings involved. So then we move on to why AWS? Why specifically do we want to look into AWS? And there are a couple big reasons. One is that it's globally scalable. It's very easy to transfer data in and out of different AWS regions, and they're always expanding to more regions. I was an intern at AWS over the past summer, and I was able to work with data from a wide range of different of AWS regions, from Seoul and Tokyo to Mumbai, Bahrain, Stockholm, London. They were basically spread out all over Europe, East Asia, North America, and we also have some smaller locations in Oceania, like Sydney or Sao Paulo. So these are applications that can do really well at scaling to a global audience. And this is important because if you have the data for your consumers that are in Europe, let's say, stored in a warehouse, in an AWS warehouse in Seattle, the fact that you're using AWS won't change the fact that it's essentially going to be slower for them to access data if it's stored halfway across the globe. So because of that, there are localized centers for, there are localized AWS warehouses across the globe, and they're always expanding to more regions. I know at least while I was there at AWS, they were planning on expanding into new regions in Africa, as well as you know, Southern Europe and the Middle East. So it always will be able to meet the demand of a more and more globalized uh, internet population, I guess. Yeah. So global scalability is a very big perk for AWS. And next we have countless services. You can kind of see what I was talking about when I was talking about infrastructure as a service versus platform as a service and software as a service here. So you can just take a moment to look at this. So as you can see up here, we have some platform as a service type, or software as a service type applications up here. So for example, they have their own mail service that's kind of like Gmail, Workspaces, it's kind of like Slack, Work Docs is of course, like Google Docs. And then you also have like messaging services, Amazon Simple Notification Service, Amazon Cognito, mobile analytics. These are prepackaged solutions that kind of overlay, some of these more technical platform as a service type options. So everything that we see up here in deployment and management is more or less software as a service. Then we have application services, which are our examples of platform as a service. You have things like AWS Config, CloudTrail, and CloudWatch, which all somehow moderate the usage of AWS. So you moderate the usage of different AWS resources according to certain security protocols that the software developers themselves can set up. So this is not something that you would be rolling out to a user, but it's also doesn't have the vast configurability of perhaps foundation services. And these foundation services, some of the very important ones are EC2 and Lambda. These are essentially compute resources, like bare bones compute resources. So you can use an EC2 cluster the same way that you would use a computer. Essentially, you're essentially renting a computer, and you can configure it as you like. And AWS Lambda is a sort of serverless application which doesn't have any servers tied to it like EC2 does. EC2, you're renting a server, Lambda, you are essentially defining a certain task, and that task will run on whatever servers AWS has available to run those tasks at the time of the request. So for example, let's say that I set up a Lambda instance to automatically convert a certain file to another file type. Lambda would be a great choice for this because you're probably not seeing traffic on your website day in, day out. Maybe there's like a certain time of day where it's more common for people to be using your website. Lambda is good because you're never paying for it at those other times of day when you're not using it. And this kind of serverless application obviously has great amount of cost savings, like we talked about earlier. And then you have storage like Amazon Glacier. It's not mentioned here, but Amazon S3 Simple Storage Service is also a great storage service that is offered by AWS. A little redundant there, but these are all examples of infrastructure as a service. You're essentially just having Amazon hold databases, like for example with Redshift or RDS or DynamoDB. You're holding just data in its purest form, or you're using pure compute resources, or you're directly like networking with the web, like in Amazon Route 53, with other cloud users, like with VPC. And these are all great examples of foundation services or infrastructure as a service. And these are just a few of the many, many AWS services that are out there. This is just like a sampling. Obviously, like this doesn't even cover the most essential AWS services. S3 is missing from here, which I believe is one of their most used services overall. Yeah. And administration and security. This is actually missing the team that I worked on over the summer, AWS Guard Duty, which does cybersecurity for EC2, Lambda, and S3. So these are all really cool, but there's definitely a lot more, and you guys should definitely look into that if you get the time and if you're into cloud computing. Yeah. And now I'll go through some example use cases here of different applications that you can build using AWS. For example, here we have an e-commerce app, right? And let's say this user is looking at a website. Uh, this website is, for example, Uniqlo.com. And you go to Uniqlo or Macy's or whatever website, and their website is directly connected to their API gateway, right? And as you can see, they're using multiple different instances of the API gateway to deal with high levels of traffic from the many, many users that are coming in, or they're trying to split up the task into the different components of of making a purchase. Like they go through the product service. So the product service gets information on the product that the user is trying to buy from DynamoDB, which is a database structure, database structuring service, infrastructure as a service. And this feeds back and it comes back to payment service. Now, the payment service, it goes into the DynamoDB. It probably pulls up like what credit card this user has used before. It probably pulls up, billing information, things like this. And it brings it back uh, here. And then we go into the inventory service. This is like an internal matter. They're just changing their online inventory of how many of a certain item they have. That's said and done. And then we move on to the next step, and it's the cart service. And this just makes changes to the user's cart that they have on the website. And here we have a very prepackaged and maybe a little bit simplified version of how an e-commerce app could work using serverless applications. And then now we have another example here where we're building a chatbot, but it's very easy using using AWS. So just like we saw in the other example, we have input coming from user, but this time it's from Slack Messenger. So we're seeing how AWS could be integrated with other applications. Slack Messenger sees a notification. This notification goes to the API gateway, and the API gateway takes whatever input the user said to the chatbot, and it passes it to a Lambda, which uses simple notification service along with a simple email service and dynamic DB to connect to a software as a service application. So, for example, here we would have perhaps examples that the chatbot was trained upon, and then these are passed to the software as a service application, which we can assume is probably some kind of ML model that is deciding what the chatbot should say in this particular circumstance. And this is a very novel example of building a chatbot, but it's essentially, you know, you can work with these different services and all of the many more under AWS or any of the different cloud services to build a huge system. Some of the big companies that use AWS are, you know, uh, actually most companies nowadays use some form of cloud computing, but specifically for AWS, the companies like Samsung, Airbnb, um, Snapchat, you know, Trello, Slack, uh, countless different, you know, online companies, small scale, non-technical, technical, all of them use some form of cloud computing. And I think it's a very important skill to learn about, um, just for employability's sake and also for just general knowledge about the field. It's always expanding, as I said, globally, and it is definitely something you should look into. And if you are interested in looking into cloud computing, I'd say the first place to start is just looking at the credits for students that are available through AWS Educate. They have a great program where they give you, you know, free credits just because you're a student. Definitely check that out. And the documentation for AWS. These are the best places to start. AWS documentation is very rigorous, and you will get a lot out of looking at it. Uh, but otherwise, that is all, and thank you very much. My name is Anurag again, and I'm here for the DS3 Workshops Committee for Spring Quarter. And if you have any questions, feel free to reach out to me. I would be more than happy to answer. Thank you very much. Bye.